recording, and it should be recording now. All right, very good. So let's answer this question first. I will go through, so there's two things that you really need to know. Pretty much the first thing is how to draw these perfectly, from the get-go every time. And the second thing is pretty much what is every single question going to be asking? And every question is going to always be asking to pretty much find the height of the tower and the strategy to find this height. It's going to be, like I said, a little bit different to your normal way, but if you can accept that and remember that for 3D trig, then it should be pretty straightforward. So let's have a read. The angle of elevation of tower CD of height h meters from a point A due east of it is 28 degrees, and at a point B due south of it, the angle of elevation is 36 degrees. Now, when I'm reading this, I usually try to stop after one piece of information. So if I see, it says the angle of elevation of a tower CD, I would usually draw a tower. There it is. And I can see down here it says B is the base, D is the base, sorry, and that would be C. Height H, height H. And then I'll continue. From a point A due east of it, so due east, you're going to draw it like that. Okay, in fact, you're going to draw all of them like that, but at least you know now that that's east. And then the angle of elevation to the top of the tower from A, so that's A, is 28 degrees, which means that has been elevated up 28 degrees. Does anyone have any questions up to this stage? Okay, and at a point B due south of it, okay, so you got to think of it like this. Remember, I'm about to draw this as a 3D triangle, right? So if this is east, this is south, these east and south are going to be 90 degrees to each other. Cool, so just keep that in mind. But on a 3D surface, we usually have what we say like x-axis, y-axis, and we've got a diagonal one, oh, sorry about that, diagonal one, which is called the z-axis. So x, y, and z, 3D. So we're going to create our z-axis, and the way you do it, you'll just create, there you go, right? And then in that, A, that was due east, B, due south of it, so that would be 90 degrees. And the angle of elevation is 36 degrees, so that becomes 36. Maybe you're already starting to see the 3D triangle. A and B are 400 meters apart. 400 meters apart, and are on the same level as the base D. Okay. I'll stop there before I continue. Does anyone have any questions at this point in time? So I want to see this as your diagram every time you're going to do these questions. That's going to be your diagram. Any questions? Everybody understood how I got everything, how I got 90 degrees there, 36 degrees there, 28 degrees there, H there, 400 meters there. Just to emphasize it a little bit further, just so you can see this, this is the ground, right? That's the ground, A, B, and D, and this is the pole, or a tower in this case, that's sticking out of the ground. And this would be my elevation. So imagine me facing here, or me sitting here, and I'll be looking up to the top of the tower. That would be my elevation. And imagine Rad sitting here, he's going to be looking at the top of the tower, and that would be 36 degrees, that elevation. And then on the ground, this A and B are south of each other, so they're 90 degrees. Okay, hopefully that all makes sense. I've cleared that up. Now, if A was not given, so I've got to say that, if A was not given, and the question was just find the height of the tower, you must do what we are about to do in A. So if the question ever says go find the height of the tower, you don't go, oh, okay, maybe I've just got to do this a new way or whatever it is. No, the technique is to exactly do what we're about to do in A. A says specifically, just go show that AD, show this one here, AD is equal to h on tan 28, and find a similar expression for BD. Well, you know if there's a tower and this is the ground, you know that a tower to a ground, if they were really good engineers, would be a right angle, right? It would be straight. So the assumption usually is going to be that that's going to be a right angle. And if that's a right angle, then you're going to find AD by just doing opposite over adjacent. So for example, tan 28 equals opposite over adjacent. And then of course you want to make AD the subject, so just multiply it up and then divide this back down. Voila, we showed that. Find a similar expression for BD. BD, well, you're going to do the exact same thing. Ready? Opposite over adjacent. Again, that's a right angle. Why is that a right angle? Think of it. There's a pole. There's the ground. That would be right angled to the ground. And then again, tan 36 equals opposite over adjacent. And then BD equals to h on tan 36. Okay, I'm going to stop there. Any questions? No, we're all keeping up with everything so far. That's great. The question could have said h cot, just be aware of that. You guys should know now that 1 on tan is the same as saying cot. So if they did say cot, that can also be represented as cot. But you know that we can't use cot in our calculators. So even if they said to prove or show cot, you can write that, but eventually when we're going to plug it into our calculator, we've got to use this version, the 1 on tan version. All good? Everyone's with me still? Okay, here we go. B. B just says, hence find the height of the tower. Now, this is what I'm trying to say with the two strategies for 3D trig. The first strategy was, you've got to draw your triangles like this, which I think you guys can get used to very quickly. Your second strategy is that when the question asks to find the height, you're not actually going to find the height. So traditionally, you had questions like this. And of course, I just said, you know, that's x, this is 50 degrees, and let's just say that's 7. Go and work out x. And you're like, oh yeah, great. Opposite of a hypotenuse, and you know, you get it. You would have solved for x, right? Or if I said that's theta, and that's 10, and that's 20, same thing. You would have actually gone ahead and found theta using sine. Now, when you get a question like this in 3D trig and it says find height, you're not actually going to go ahead and find the height here. The triangle we're going to usually use is this bottom triangle. Now I say usually because that's like 95% of the time. 5% of the time it's this top one here. So this large one on the outside, if you can see that. Triangle A, B, C. But usually it would be this one. More than 95% of the time it's been this bottom one. So you're actually going to find the height by using this triangle down here. And the reason why that works out is because you already have AD, this bit here, in terms of h. You already have this bit here in terms of h. You already know the distance here, which is 400. So we're just going to use Pythagoras, and it must equate, because it's a right angle, to solve for h. So it's going to look like this. AD squared, so this squared, plus BD squared must equal to 400 squared. Yeah, A squared plus B squared must equal to C squared, Pythagoras. And just so you know, I would say if it's 50-50. 50% of the time it's Pythag, 50% of the time it's cosine rule. So you might need your cosine rule as well, depending on the question. So depending if this was a right angle or not. In this case, it was south, so that was easy. The next one we won't do a south one, and I'll show you that. What's AD? AD is h on tan 28. So that's going to look like this. h squared on tan 28 squared plus bd squared, this guy squared. So that would be h squared on tan squared 36, right? Must equal to 400 squared. Of course, don't forget I'm trying to solve for h, so I would factorize it out. I'm almost done. Any questions? Okay, the last line, all you're going to do really, you're going to plug this into your calculator. It's going to become a number. You'll divide this by whatever number that was, and then you're going to square root it. So I'm just going to write square root of answer. So this divided by this, and then we're going to see if you guys can do all of it in your calculator. So first put this into your calculator. Then once you worked out the answer, you're going to just press AC, then do 400 squared divided by the answer, and then we're going to square root that answer. So, anyone confused on what to do with their calculator at this stage? Because I'm about to put it in, I can walk you through it. Okay, so let's see. I'm going to put this in now. Make sure you can get the same answer as me. Squared, oh, to put squared in your calculator, do we all know how to put this into our calculator? 28?
No.
How do you do the square?
So you're just going to do this 1 on tan, and then you'll open a bracket, right? You put 28, you'll close your bracket, then you just put squared at the end of it. But when we write it, you must be writing like this. We don't write it like this. So your calculators, unfortunately, can't put the squared there. So, but yeah, that's all you're going to do. Plus, and then 1 on tan 36 squared, press equals. This became about, I think, 5.43. Then I'm just going to put 400 squared divided by answer, and then I'm going to root it. Hopefully, you guys get something like that as well. I'll wait for you now. Please confirm if you did get that answer.
Yep.
Yes? Who said yes?
Yeah, I got that too.
Oh, great. Anybody else? Other than Lisa? I only heard Lisa.
Yep. Yeah.
Yeah? Good.
Sam, how did you get 171.63?
So did you get this bit, 5.43?
Yeah.
Okay, then you would have done, well, and then what would you have done? You would have usually done this number, so 400 squared,
Yeah.
divided by this, so divided by whatever all of this was.
Yeah.
And what do you see? Press equals.
I got, oh, wait 1 second, let me
29,000.
read that.
So you gotta remember there's a h squared.
When I put that into my calculator, I got like 200 and something.
So
I'll redo
400,
it.
wait, did you put this into your calculator? You got 200 something?
No, I got the 5.43
Yes, beautiful. Then you did 400 squared.
divided by 5.43.
Yes. Press equals. Right, now that's h squared. So what are you going to do now?
Okay.
You're going to square root it.
Okay, got it.
Okay, cool. Now, so obviously you guys can see we found the answer. I mean, h equals, we found it, but we didn't find it using your traditional methods, right? Do we get what I'm trying to emphasize by that? We're not finding h. So if you're asked to find the height, you're not actually going to go and find the height. So be careful of that. Whereas every other question you're going to be doing, other than 3D tricks or all your 2D stuff, when it says find the height, you will find the height. whatever it is, the normal way. You're meant to work towards finding the height. This one here, you're actually going to work towards a different triangle to find the height of the other triangle. Okay, any questions before I continue? No, everyone's good. Tiana, just so you're aware of something, imagine your answer was, I think it was like, I don't know, 20,000 or 200,000, whatever it was, yeah? You know that height is going to be way too big.
Yeah.
So I have seen a lot of students actually forget the square root in exams, and then sometimes I just go back to them, I'm like, hey, like if you just looked at the answer and just told yourself, wait, 20,000? Because it's always going to be that big. You're like, wait, yeah, that doesn't sound right, does it? No, you should have square rooted. So if you ever see it's a weird number and you're like, wait, what am I meant to do now? Usually at that stage it means you've got a square root.
Okay.
Cool. All right. Let's go with B. All right. B is going to have a bearing as well now. As well as an elevation, it'll have a bearing. But should be okay if you're doing it the way I've been teaching it to you. You should be okay with this. Here we go. The angle of elevation of a tower CD. Well, already, you know, I'm going to draw this because I just told you it's going to always be like this, right? H from a point A due east of it is 40 degrees. So the elevation is 40 degrees. From a point B, so watch this now, that's B, from there, the bearing of the tower is 42 degrees. So whenever we're doing bearings, we draw compass bearings, right? It's saying this is 42 degrees. Can we see that? Again, imagine I'm standing there and I'm facing north. And then the idea is I'm on a bearing, I can see the tower at 42 degrees. So that would mean that angle there to the tower would be 42 degrees. Any questions about that bearing? That makes sense, the way I just drew that? And that's how you're always going to do your bearings for that. Okay. And the angle of elevation is 35. So again, right, and that would be 35 degrees. A and B are 200 meters apart. Let's do it again. There it is. 200 meters apart. And on the same level as the base D of the tower. Same level as the base D. Okay. Show that BDA equals to 132 degrees. Interesting. Well, what do I know? I know this bit here is 42 degrees. So I also can tell from alternate angles, right, that is also 42 degrees. And then, of course, that is 90 degrees. That's just 90 to there. So what would the whole angle this time be? 90 plus 42, which equals 132. So your answer in A, you would have obviously drawn your diagram. So from diagram, 90 plus 42 equals 132. Big. Any questions before I continue from that? If you're just wondering, with the question above, look, it actually said B is due south of it. So B is due south of from A. Due south of it, or due south of here even. That's 90 degrees. Whereas this one is saying B. From B, the bearing of the tower is 42. So from B, the bearing of the tower is 42 degrees, which would be on the ground. So, okay, if that makes sense, then we'll move on. Show that BD is equal to H tan 55. Okay, anyone have any ideas of how I'm going to bring 55 in? We're looking at this triangle. How am I going to bring 55 in with this triangle? Come on. Do we know what angle this is? Does anyone know what angle this is?
Would you use angle sum of triangle?
Yep, so what angle is this then, Brad?
90.
That's obviously 90. Why is that 90 degrees?
Because that thing's straight.
That thing's straight and that's on the ground.
Yep.
You would assume that's 90 degrees, and that angle there would be what?
180 minus 90 minus 35.
Which becomes obviously this.
55, yeah.
Yeah, that's the whole point. That's where you're getting 55 from.
Yeah.
Otherwise, if I use this angle, you're going to get it looking like this. H on tan. H on tan. If you're going to use this angle, you're obviously going to be going opposite or adjacent, which will be multiplied now. H times tan. So it just depends on which angle you're going to do, but it'll always be tan. All right, here we go. Well, you're going to use this angle, opposite, over, adjacent. So it'll look like this time. Tan 55 equals opposite, over, adjacent. And of course, you guys can see BD is equal to H tan 55. And it says find the similar expression for AD. For AD, well, again, I'm assuming this will be 90 degrees. That means this becomes 50 degrees. You just do the same thing again. Tan 50 equals opposite, over, adjacent. AD equals H tan 50. Any questions? No? All good? Okay. Let's do C. C just says now, hence find the height, and we're trying to do it to the nearest meter, so keep that in mind. I'm going to do C here. C. All right. Anyone have any ideas of how I'm going to be able to find the height? Find this height.
AD squared plus BD squared equals 200 squared.
That won't work in this case, and why won't it work?
I don't know.
Okay. When are you allowed to use the formula you just said? What's it called again? What formula did you just use?
I don't.
What's that famous guy?
Pythagoras.
Yeah, that guy.
Okay.
When are you allowed to use his theorem? What kind of triangle? No?
Right angle?
Yeah, it must be a right angle. So we used it here only because it was a right angle triangle. Is this a right angle triangle?
No.
No, it's 132 degrees here. So we can't exactly use Pythagoras. You've got a side, another side, and a third side. So you've got three sides, 1, 2, 3, and an included angle. Does anyone know what we're going to use other than Pythagoras?
Would it be the cosine rule?
It would be the cosine rule. Do you remember what the rule was? Do you remember what the formula was?
Is it A squared equals B squared plus C squared?
I do C squared equals A squared plus B squared. But yeah, keep going.
And minus 2AB
Yep.
cos C.
That's it. C squared equals A squared plus B squared minus 2 times A times B times cos C. And what was important about cos C? Cos C had to be opposite this C. So, for example, these two are going to be opposites of each other. Okay, and all you're going to write is obviously now 200 squared equals A squared, which we'll just pick this one, whatever, doesn't really matter. H squared, tan squared, 55 plus H squared, tan squared, 50, right? The other one, minus 2 times, I'm just going to scroll up now, 2 times H tan 55 times H tan 50 times cos 132. Okay, I'm just going to stop there. Everybody okay with that line? C squared equals A squared plus B squared minus 2 times A times B times cos C. Okay, now the next line, look, you got to remember something. The way I teach, it has to be at like for example, I would teach you guys at the way I would need you to do it if you were going to come first in the state. So it's got to be at like at an extension level or an extension 2 level. It's got to be really fast, really efficient, less room for mistakes. All right. So what I need you to realize is the next line, just like we did before, we're going to factorize our h squared out. So h squared is there, h squared is there, and h times h, even in here, would give me h squared in this whole expression. So what I'm left with is this, tan squared 55 plus tan squared 50 minus 2 times tan 55, tan 50 times cos 132. So 2 times tan 55, tan 50 cos 132. Okay. Anybody have any questions there? Because that's pretty much meant to be the hardest line, knowing or learning how to factorize this properly. Okay. If not, then I think you guys know what I'm about to say. Obviously, this is going to be a number which you're going to plug into your calculator eventually. You're just going to do this, divided by, we'll call this A, divided by A. That still gives me h squared, and then whatever this becomes, we're going to square root it. And then we should get our answer. So, if we've got no questions, let's try to put all of this into our calculator, and then 200 squared divided by that, square root it, and let's see if we can get our final answer out.
Yeah, 83.
Nice. Anybody else got it out yet? Lysandra,
Yeah, I got that answer.
Daniel, you got it? Nice. Lysandra?
Yep, I got it.
Yeah, good. And then girls?
Yeah, got it.
Nice.
Got it.
Beautiful. So, any questions? Like Lisa, Tiana, do you feel like you girls are firstly comfortable with everything I've just done there? Are you starting to realize, I guess you're looking for this side and then this side, and eventually we're going to use this side, and this side of this triangle at the bottom to eventually find my height. Girls, you think you're getting that? Does that all make sense?
Yeah, that makes sense.
And then,
It
I mean,
makes sense,
eventually you're going to realize, obviously, when it would be a cosine rule compared to a Pythag question. But pretty much, yeah, if there's bearings, it's always going to be a cosine rule question, because then it won't be a right angle anymore. Okay. And boys, no questions from you guys? Like, everything's fine, everything made sense?
Yeah, it's all good.
Or
You feel like, do you feel like you can, because you know how many marks this is worth? Let me show you. So this is worth 1 mark, this is worth 2 marks, this is worth 3 marks. So this in an exam is worth 6 marks. This is not small, right? So it's pretty serious topic. But if you're feeling comfortable with the way I've done it, that means I have really simplified it, which is good. You guys are getting it, that's amazing. So let's try another one, and then I think we can start our revision. Yeah, let's do that. Question 5. Let's see how we've got to do this one. From a point from a point due west of tower QT, angle of elevation on top of the tower is 60 degrees. All right, so this time it says from a point due west of the tower QT. Okay, so this time I guess you can say it's going to look like this. It's going to the left, because due west. The height h, that is capital A. That's what I have so far. The angle of elevation to the top is 60 degrees. From B, a point 200 meters due south of A, due south of A. Okay, it's down here. The angle of elevation to the top of the tower is 30 degrees. All right, so just changed a little bit, only because this one specifically says due south of A. All right, but don't worry, you're going to still do that. Watch what will happen. This was point B. This is 200 meters due south. And watch. Really bad, but I tried. The angle of elevation of the top of the tower is 30 degrees. So, let me see if I can get this out for you guys. Can we see a 3D triangle happening there?
Yep.
See it?
Yeah.
Yeah, correct. All right. So like for example, if I mean, the way I'm trying to see it is this bit here is sticking, like, so they're pretty much sticking out of the ground. Think of that as the ground, and these are your triangles that are sticking out of the ground. And then that one there. And that becomes a 3D tree. All right. Only because of this one that said 200 meters due south of A instead of the tower, which is usually the case. Is it? Or am I just overcomplicating that? Hold on. Isn't it usually due south of A? And another point due south of it of the tower. Yeah, it's definitely right. Okay, the points A, B, and T, all lie on the same level ground, which I think we can see. Show that AT is equal to H on root 3. Okay, show AT. Anyone can help me out with A? Actually, Rad, try. Let's do A together. What are you going to do to find AT?
So to go 10, 60 degrees equals H on AT.
60 equals H on 10. Oh, wait, H on AT. Sorry.
AT.
Yep. And then what do you think this comes from? Where do you think this one on, or this root 3 business comes from?
That's from the exact value of 1060.
Correct. So what's 1060? Plug it into your calculator. Give me your answer.
Root 3.
Root 3. And then, of course, you're just going to multiply by AT.
Yeah.
Equals H, and then you're going to...
Yeah, and then you get it. Yep.
One more. Good man. B. B says, show that H, and that's it. See? It doesn't even say what to do. It just goes, all right, show this. We didn't put in our last one, which was 30 degrees. This was 30 degrees, right, you guys? That was 30 degrees there. It just goes show. Anyone have any ideas of how I'm going to do that? Come on, someone's got an idea. Think about what I'm still missing.
Will we do the cosine rule again?
Not yet. You can't get that. You can't do that yet. Okay, let me go up. What did I have to do? What did I do in B? Tiana, go tell me. What did I do in B first? Tiana?
Sorry.
That's right. B. Right. What did I need?
Okay.
BD. And then what did I find?
You had to find the other angle,
Other side, you mean?
other side, yeah.
Right. No, wait. Yeah, I found the other angle. I get what you're saying. I found this angle. Yes, sure. But the point was, the whole point of the questions is to find this side and this side. Let's go
Oh,
up.
you have to find AD.
What about this one?
Well,
I found AD and then I found BD. Without the second side, so you guys have found AT. Good on you. But what haven't you found yet? What haven't you found yet?
QA and TV.
QT and BT. QT you don't need to find because that will be done in a very different way. So that's the whole point of the question, to find H. You don't need that. But BT, yes, I haven't found BT. The triangle, if you guys are not seeing which triangles I'm going to be using, remember it's the one on the ground. It's that one there, right? That's why you got that 200 meters. So you haven't found BT. So before you can even show this, you guys got to know I can't do this, right? They tricked you. You're not meant to get tricked. If you find one only, you're meant to tell yourself, no, I'm meant to find both of the sides. I need AT and I'll need BT. So we're going to do it again. Tan 30 equals opposite over adjacent. And then put tan 30 in my calculator. I see it becoming 1 on root 3. Which means BT becomes root 3H. BT cross multiply becomes root 3H. Now that I've got my AT and BT, I am going to use something in triangle ATB to actually work out the height. And Tiana, I think you said cosine.
Yeah.
All right, to use cosine rule, you need an angle that's down here. Do you have an angle?
30. Oh, wait, no.
30 degrees. 30 degrees is the elevation, right?
Yeah.
So don't get that mixed up. That's for this triangle, QBT. So you want an angle in TAB. So anyone know one of the angles in TAB?
A would be 90,
Yes, and where is it 90?
like on A. So BAT.
And A. Yeah. Why is that 90 degrees? Because this said this is west and this is south. So west and south are specifically going to be 90 degrees there. Does that make sense, Tiana?
Yeah.
And then, of course, you're going to use Pythagoras, which would look like this: 200 squared plus AT squared, so this guy squared, H squared on root 3 squared is just 3, equals BT squared, so 3H squared. You guys get that? 200 squared plus this one squared must equal to, and then again, we want our H's on one side. Me, I don't like this 3 either. So personally, I will just multiply by 3 straight away. So 3 times 200 squared plus H squared is equal to 9H squared. And that way it's just a lot easier to deal with than fractions. So minus, and then of course, just going to divide by 8 and then square root. nearest meter would be 122. Oh, wait, sorry. Question said show it's 50 root 6. So I can't leave it as 122. So go back. Very wrong. Show means keep it exact. So plug all this into my calculator and it will say 15,000 equals h squared. And then of course it gives you the clue here. 15,000 is 50 squared times 6. So the idea is that becomes h equals root 15,000, which is 50 root 6. If you want to double check it in your calculator, you can plug them both in and you will see that it works. Any questions for me at this stage? Calculate the bearing of B from the base of the tower. From the base of the tower. That means you're trying to work out this from here. Try to work out that. Cool. To be able to work out this angle, I think you guys can see, it's going to be a little bit hard. So what I am going to do, I'm going to find this angle. Once I find theta, I'll just have to do 90 minus that. I can work out this, or just go 270, take away theta. Really. So to find this bearing, you'll have to find this theta in here. To find that theta, there's a lot of ways. You now know what h is. So realistically, you could put h for AT, and I'm going to do that. So I'll just show it to you guys. I'll draw the triangles first. This was 200. This was AT, but AT is equal to h on root 3. And we know we just found h as 50 root 6. Root 2. So AT equals 50 root 2. And then, you could just go theta is opposite over adjacent. So tan theta equals opposite over adjacent. Find theta. And these strategies that I'm showing you, like for the fact that I had to find theta here to find the bearing, it's always the case. And if it wasn't a right angled question, instead of doing SOHCAHTOA, you'll be doing the sine rule. So after using the cosine rule to find your height, if you ever had to do bearing, it'll be via the sine rule. Inverse tan, that gives me 71 degrees to the nearest degree, which means bearing equals 270 minus 71, which is 199 degrees. Any questions, you guys, for that? Because if you don't have anything else, I'll be starting our revision, unless you guys want me to do another 3D trig question. Okay. I'll save this for you guys. Well, actually, I don't need to save. I've already sent you this booklet. So 3D trig, you can see them all. Okay, close this. That's already been sent to you guys. We've already done this. Does anyone actually want this this one here? The one we're just writing?
Yes, please.
Yep. Okay. Save. Thursday. Advanced. Save. I'll send that across once we finish up. All right, Trig, let's just do a revision for the next hour, and then pretty much it's done. Okay, trig ratios, SOHCAHTOA, so sine theta equals opposite of hypotenuse, cos theta is adjacent over hypotenuse, tan theta equals opposite over adjacent. The question says, if sine theta is equal to 2/7, determine the value of cos and tan. So whenever you're given sine and you need to find cos and tan, you need to actually work out this as a triangle. You guys might remember this. Theta equals opposite over hypotenuse, and then of course you have to use Pythagoras to work out this bit here. 7 squared, take away 2 squared. 7 squared take away 2 squared is 45, so this becomes square root of 45. And then after that, cos theta is what? Opposite over, sorry, adjacent over hypotenuse. And tan theta is opposite over adjacent. Rationalize. Square root of 45. I mean, I'll tell you now, you'll get full marks for this, but I just want you guys to get used to rationalizing. Again, at state level. 45 is 9 times 5. Square root of 9 is 3. 3 times 2 is 6. And that should be the answer. Can that get simplified? Yes, 6/45 gets divided by 3. And that is pretty much the perfect answer that you would be looking for. You can't do anything else to that. And obviously root 45 up here, same thing can be written as 3 root 5 on 7. Okay, so pretty much the lesson learned there would be anytime you're given a trig, you got to find a different trig, you must draw your triangle. If I also said that I know something about the angle, so I said, oh yeah, cos theta must be greater than 0 or something like that, that's when we have to introduce our all stations to central, which you will see coming up. These ones, I think that's year 9 work, so you can do that at your own time. Again, I'll send you this booklet with solutions. 60 minutes, 1 degree, 60 seconds, 1 minute. The cutoff for the mark is now 30 degrees. So when you're trying to round, if you're at 30 minutes, then you go up to the next degree. If you're at 29 and under, you keep it at that degree. Exact ratios, we didn't do it via the triangles. We did it via square it and then mentally square root it. Just the faster way, and eventually you'll get these answers. So here it says find the exact value of this. So if you guys want to do it with me, sine 45 becomes 1 on root 2. Cos 60 just becomes half. Cos 45 becomes 1 on root 2. Sine 30 becomes half. Anybody not understand how I got those for? That's a difference of 2 squares. I can just see that. So I know it's this one squared, which is a half, minus this one squared. Plug it into your calculator and you should get a quarter. Any questions there? No. Evaluate sine squared 45. Again, you just go sine 45 and then you square it. Just becomes a half. You don't need to square root it because you're trying to actually work out the squared version. Minus 1, which becomes negative a half. Am I going too fast? Okay. All right. Oh, yeah, I'd rather do an elevation depression one. Let's go with that. So that one's easy. Easy. Yep, let's do this one. Okay. The diagram above shows a boat at sea. The cliff is vertical and 84 meters high. The rocks are 145 meters from the base of the cliff. From the top of the cliff, the angle of depression to the boat, depression, always to the horizontal, and then it depresses down. Elevation, it elevates up. Don't forget, depression and elevation are the same angle because of your alternate angles, Z angles. So that must be 24. And then copy or trace. Yay, got 1 mark. That was easy. Calculate the distance from the rocks to the boat. Calculate the distance from the rock to the boat. Okay. Anyone have any idea of how I'm going to solve for this? How I'm going to find this, which we'll label it as Y. Anyone have any idea of how I'm going to find Y? You don't have to say the answer. It's just what your logic is going to be. How are you going to direct your math to be able to eventually find Y?
I would use tan 24.
Yeah, I'm saying instead of telling me the answer, so what's going to eventually happen? Like, what are you actually going to find?
Well, you're going to find the total length of Y and and you subtract 145.
That's it. That's what I want to know. So if you can understand the logic, then the math is very easy. You're going to find this to this, which we'll label as X. You're going to find the whole distance of the boat. And then once you find the whole distance of the boat, you'll just subtract 145 and you'll find Y. Very easy. You're going to know the logic. So you're just going to do the big triangle, tan 24, tan 24, opposite, over adjacent, the whole triangle, which is X. Solve for X, which is $188.66, and then of course Y equals 188.66 minus 145. 44 meters. 3 marks. This is an exam question. See how simple it is? Okay. Any questions? Scroll down. We'll do a bearing question. Yeah. Okay. Bearings that are taken, by north. So find the bearing of the following from O. Don't forget it starts from north. So the bearing would be 180 minus 50 degrees, which equals to 130. That again starts from north, 270 plus an extra 10, 280 degrees. Let me know if I'm going too fast. This one is going to be 270 minus 40, 230. This, just 20 degrees. In bearings, an understanding of the words of and from is essential. Consider the following situation. When we say calculate the bearing of Perth from Sydney, this actually means from Sydney, so there's Sydney, there's Perth. So what you're trying to work out is this bearing. From Sydney, pretty much to Perth. So calculate the bearing of Perth from Sydney, very important you get that. Calculate the bearing from Melbourne to Darwin. Okay. From Melbourne, I look at it always from, that's my starting point. So from Melbourne to Darwin. That's the same as saying the bearing of Darwin from Sydney. Of Darwin from Sydney is the same as saying from Melbourne to Darwin. Okay. Okay. That's all. Nothing. Let's do a question that looks. Yeah, that looks just about right to start. Triathlete cycles 20 kilometers from the end of the swim leg on a bearing of 200 degrees to the finish line. Okay. Always draw your compass bearings. They help. 200 degrees is there, right? 90, 180, 200. So if that's 200 degrees, you know that that little bit in there is 20 degrees. Cycles 20 kilometers from the end of the swim leg to the finish line. So from here to here, cycle 20 kilometers to the finish line. You assume that would be the finish line. How far have you traveled in a southerly direction? How far south? Well, that's very easy. Adjacent hypotenuse. So cos 20 equals adjacent over hypotenuse. So always draw these compass bearings and then it doesn't look too hard. What is the bearing of the end of the swim leg from the finish line? So from the finish line, that's the finish line, right? You finished here. So from here, what would the bearing be? Well, if you use alternate angles, look, if that's 20, that's 20. Right? That's why I draw these bearings everywhere. Wherever you're at, you're going to draw these compass bearings. And then the bearing, so bearing equals, of course, just 20 degrees. I'll pause there. Any questions for me at this stage? Okay. Move on. Then we learned some trig identities. So cosec is equal to 1 on sine, and the trick is to always look at the third letter. So third letter, first letter, third letter, first letter, third letter, first letter. So sec, 1 on cos, cot, 1 on tan. You can't put these three in your calculator. You'll have to use them as 1 on sine. So if I came and said, find me cosec 30 degrees, you're going to actually have to do 1 on sine 30 in your calculator. And then you'll put sine 30 only in your calculator. Sine 30 in your calculator is a half, so 1 over half becomes 2. And that would be the answer we were looking for cosec 30. Tan was also equal to sine on cos. There's a little proof here, you can look at it at your own time. Cot is equal to cos over sine. So if tan is sine on cos, cot can also be written as cos on sine. Complementary angles. Yeah, I guess we didn't talk about complementary angles. All it's saying is, I'll prove it because it'll make a bit more sense when I do prove it. So watch this. If I say sine theta, so sine from here, that would be opposite over hypotenuse. So that would, you would say b over, you know what, I'm just going to use numbers because I think it's easier. So let's make this into a 3, make this into a 4, make this into a 5. So sine theta would be 3 over 5. And then sine 90 minus theta, so that the angle up here, whatever this angle would have been, you would have said opposite over theta. So this one would have been 4 over 5. Cos theta, cos of this one, adjacent over hypotenuse, would have been 4 over 5. Cos 90 minus theta, so from this angle, would have been adjacent over 5, over hypotenuse, so 3 over 5. Anybody lost at what I'm doing? Okay, then what you've just proven is that sine theta is always the same as cos 90 minus theta. And vice versa. Cos theta is the same as sine 90 minus theta. So in other words, you've just proven this. Sine theta is the same as saying cos 90 minus theta. So let's try it out. Like, put this into your calculator. Put sine 20 degrees, and then put cos 90 minus 20, which is 70 degrees, and guess what? It'll give you the same answer. Try it out. Confirm that. 0.34, 0.34. So we get that? Sine and cos are going to be complementary of each other, which, yeah, it just means sine theta is the same as cos 90 minus theta, and cos theta is the same as sine 90 minus theta. So the angles of your sine and cos must add up to 90 degrees. That's another way you can look at it. That's how I personally do it. So this plus this must equal to 90. Or if you don't have this, then 90 minus 20 must equal to this one here, which is 70. But I like to do it by plussing. Okay. Then everything after that is going to be with its codes. So sec and cosec will be complementary to each other. Sec and cosec. And then tan and cotan, which is cot, are going to also be complementary, which means they will add up to 90 degrees, and they will add up to 90. So here it is. Tan theta is the same as cot 90 minus. Look, we rarely use this. If I had to say, this will be worth 1 mark, if that, in your exam. Overall, the whole paper. So it's not a big concept. I mean, of course, you're going to know it, but not anything that's too important for most of our trig questions. So tan theta, cot 90 minus theta, cot theta, tan 90 minus theta, cosec. But pretty much sec and cosec are complementary of each other, and tan and cotan are complementary of each other. That's pretty much what you want to memorize. You just got to memorize one of them. So sine and cos, sec and cosec. The way I remember it, I just said it to you guys. The first one, and then it's cosine, cos, sec, cosec, tan, cotan, which is cot. So those guys are going to work together. Then we did this my way, so I think we're okay with this. I'm going to move past this so it doesn't confuse you the way the textbooks will be doing it. That's how we did it. All stations to central. That was theta. That was 180 minus theta. That was 180 plus theta. And in this quadrant is 360 minus theta. We're going anti-clockwise. And don't forget, if sine was negative, that means it would be here and here. If tan was negative, it would mean it's here and here. And if cos was negative, it would be here and here. And don't forget, if you're at any point, like let's just say if we're here, you're allowed to add 360 degrees to that angle. It won't change its position. And you can again add another 360 if you wanted to. It won't change its position. It's good to remember that because some of your harder questions requires you to add 360 because of your angles. Only sine is positive. I think we've spoken about that, so we'll move on. Okay, let's draw it. Let's do most of these because they're important. Determining which quadrant is sine theta less than 0. Let's start with you, Rad. What's the answer for the first one? Rad, you there? Sorry? Was that Eden? Is Eden here? Oh. Hi. You'll get the video. Did you just join now?
Yeah.
Okay, that's cool. Yeah, you'll get the video and then you probably can stay for the next class. But let's,
Okay.
yeah. Eden, tell me, sine theta is less than 0?
In TNC?
Yeah, so third and fourth.
Yep.
Lisa, cos theta greater than 0, which quadrants?
C and A.
Yep, so first and fourth. And then Tiana, tan theta is greater than 0 and cos theta is greater than 0. So where
A.
tan is positive and cos is positive, the only way tan and cos are both positive is in first only. Good job. Determine the exact value. Daniel, what are you going to do exact value of tan 330? Don't overthink it. Exact value, tan 330. What are you going to do? Calculator. Plug it into your calculator. What does it say?
Negative 0.5.
And then what are you going to do? Square it. And then? So what's my answer?
Third.
No, not a third. You meant to square root it. Mine is 1 on root 3.
Well,
Yeah?
Yeah.
Because you meant to mentally square root it. So Daniel, you know what you're going to do over your holidays. You're going to watch those videos over again. In fact, just so you guys know, from the Thursday class, Aya was telling me that from the Thursday previously, she watched the video 3 times over the week. And she's like, Sam, then I came into the class, I felt 100% comfortable. But she's like, I had to watch it 3 times for me to understand absolutely every single thing. She didn't delay it. She took responsibility. So same thing with you guys. If you're feeling like, oh, I kept most of it, but I forgot, or I am going to forget maybe that 3D trig stuff that we did, just go back and watch it, and don't feel like it's going to happen the first time or the second time. Watch it 2, 3 times until you go, I fully get it now. Lissandro, sine 225. Give me your answer.
I got negative 1 on root 2.
Correct. So, Rad, are you there now?
Yeah, what's up?
This
We
one,
asked
what's the
him,
answer
man.
for C?
C.
Yep.
Sine. Would it be negative 1 on 2?
No.
I don't know.
What did you do? What did you put in your calculator?
Sine 210.
No, but why didn't you put sine negative 210?
Oops.
Is it because I said you can't put negatives? Is that what you're thinking of?
Yeah, I confused her with the other thing.
Okay, wait. That one is inverse sine. We don't inverse a negative. This is wrong. You understand that?
Yeah, okay. I confused.
Inverse. Just the inverse. I get it. That's why I asked that. Inverse.
Yeah. Okay.
Yeah, so what's the answer?
Now, one and two.
1 on 2. Easy. All right, Daniel, let's do this one together again. Cos 570. Plug it into your calculator. What do you see?
Negative 0.866.
Good. And then you're going to square it and then mentally square root it. Try to see if you can give me my final answer.
3 square root 4.
Negative. You're
3
close.
square root 4.
It's root 3
Oh.
on square root of 4, which is 2.
Yeah.
3 over 4, when you square root it, becomes root 3 on 2.
Yep.
Cool? All right.
Yep.
Tan theta equals 3 over 4. Lisa, let's do this one together. Are you ready?
Yeah, go ahead.
All right. So what do you think my technique's going to be? If I've been given tan theta, I need to somehow work out sine and cot. What must I do first?
Tan equals sine over cos.
Yeah, no, I'm not going to use that. What if I change this to just cos? Let's just say that was a cos. Now I needed to find sine. What must you have? What must you create? I said it before. Yeah? Someone want to help out? You're given tan. How are we going to be able to find sine?
Would you
Draw
draw
a triangle.
Yeah,
Draw a
correct.
triangle.
That's it. It's got to be that question. Right, Lisa? The one we just said before. We were doing before. I said if you're ever given tan, you want to find a different trig because you're given opposite over adjacent. Opposite over adjacent. This one, to find sine, is opposite of a hypotenuse. You need to actually draw your triangle out. So 3, 4, 5. Do you understand how I got everything in here? Oh,
Yeah.
3 there, 4 there. Okay. If tan theta equals to 3 over 4 and cos theta is less than 0, okay, you know I don't do it like this. We have to just quickly draw this up, visualize it a little bit better. Tan is positive, so because tan is positive, right?
Mm-hmm.
Here and here. It's saying cos is negative. Where is cos negative?
S and T.
So cos is negative in S and T, but you know T is positive already. So it's just going to be negative in this region. T is already positive, so that's not a problem. So we're going to find sine theta now. Sine theta is equal to opposite over hypotenuse. So what's your actual answer for sine theta?
3 over 5.
But it's meant to be negative because cos is less than 0 here. So the answer is negative 3 over 5. Actually, I probably confused you here when I said cos is negative here and here. Tan is positive here and here, right?
Mm-hmm.
If tan is positive here and here, it must be negative here and here. Which is why cos is being negative anyways.
Yeah.
Does that make sense? So we didn't even, technically we didn't need that because we know the way I've been doing it, but I mean, it just justified it for us. So sine theta is negative 3 over 5. And then you need to find cot theta. But you know cot theta is the same as 1 over tan. And tan is just 3 over 4. So this will
Would
become...
this be reciprocal? Yeah.
Yeah, reciprocal. 1 over a fraction is just a reciprocal. Okay, let's try this one. Tan theta equals negative 1.2. Eden, let's do this one together.
Okay.
Now, 1.2, we don't like that, so you're obviously going to write it as what? Tan theta equals negative what? Just so you can see it a bit better. What are you going to change?
You're going to change it to fraction.
Then, what are you going to draw?
Triangle.
There's my right angle, there's my theta, opposite, over adjacent. Work out this one, 6 squared plus 5 squared, 61. So that becomes square root of 61. Then, what am I going to draw up here?
The quadrant.
Oh, stations to central. It's saying tan is negative. Well, tan is negative here. Sorry, yeah, tan is negative here. We don't know anywhere else yet. Because you don't know, it could have been in C, it could have been in S, right?
Yeah.
Then we go back to this one. It's saying that the angle must be between 270 and 360. So where's that?
C.
In C, which means it's positive here. So therefore this is also going to be positive, which means this guy's going to be negative. Does that make sense? Eden?
What do you mean that? Wait, what do you mean it's going to be positive A and B and negative S and T?
Well, okay, wait. You know you already know tan is negative because it gave you that. But it's saying the angle
Yeah.
must be between 270 and 360, so it's lying somewhere in here.
Yeah.
If your angle's lying in here, that means it's positive here.
Yeah.
So if it's positive in cos, what does that also mean about A? It's also positive, right?
Oh, yeah.
And then what about sine? Sine is negative. Yeah. Right? If cos is positive, isn't it usually sine and tan are negative?
Oh, right.
Yeah.
Okay.
Same as this one. Tan was positive, so therefore sine and cos were negative, but you just got to get it out. Okay, and
I
then?
get so confused.
No, that's cool. Cot theta. Cot theta again is 1 on tan,
Yeah.
1 on negative, and what's your answer?
5/6. Negative.
Cot sec. Sec theta is 1 on what?
Root 61. Wait.
Wait.
1/cos.
Sec,
Cos.
yeah,
That's
what 1 over cos. And then cos is adjacent over hypotenuse. So 5 on root 61. Again, just reciprocal.
Root 61 over 5.
And then last one. Cosec theta is 1 on sine. Oh, wait, hold on. Cos was positive, so we left it as positive, yeah?
Yeah.
1 on sine. Sine is opposite over hypotenuse. So pretty much root 61 on 6 when you reciprocal as well. But
And it's negative.
it's got to be a negative. And that's the extra bit you guys got to remember, because in your formula and stuff, it won't have a negative. So you've got to know to put a negative in. The sign is negative. All right. Okay, and then we're not doing it like that. And then we learned this identity. Cos squared plus sine squared is equal to 1. And then we learned that we can make cos squared the subject by doing 1 minus sine squared.
Yep.
And same thing with this. I didn't exactly teach you guys these two. I don't do that on purpose for advanced students at the beginning. It usually confuses everything else, and then they start going, I don't get it, there's too many. So I've left it. You don't actually need it, because anytime you want to prove this, it just comes from this. So you'll need to have this anyways. So if you're really good at this, you'll always be able to get these out if it's ever required, which won't be a problem. Because, I mean, imagine the question said to prove sec squared, and you've proven cos squared. Well, sec squared is 1 on cos squared, so it's just going to be 1 on 1 minus sine squared. And then, I probably have to show it to you guys. Let me think. Well, let's see. We'll get to a question, and we'll see if the way I do it, which is going to be this way, if you guys will get it or not. So let me quickly find one before I do those. See, none of them require it. That's the thing. You never use it. But look, imagine I needed to use this. So just to show you. 1 plus tan squared is sine squared on cos squared. Sec squared is 1 on cos squared. You multiply everything by cos squared, and look, you end up with the result that we're using. So I can promise you'll never use these, because you'll always just eventually get it to this. Here we go. Let's do these. Let's start with Tiana. Let's start with you. Cot theta. Do you remember what cot theta equals to?
It's Cos theta over
There's
sine
two.
theta.
You are correct. There's two of them. We'll probably want to use this one. Remember, what are you going to do?
I'm going to. Would I times them both by sine theta? And then they cancel out. Sine theta cancels out.
Yeah. Right? Don't they just cancel out instead of
And
multiplying it?
cos theta.
Cos theta. Great. Lisa, let's do the next one. Again, what's cos
Okay.
theta equal to?
Cot theta is cos over sine.
And then times by square root. What does 1 minus sine squared become?
Cos squared.
And then what happens to the squared and the square root?
It cancels out.
I'm only allowed to do that because there's no plus 1 or anything like that, right?
Yeah.
So even if this is plus 4, it's very tempting to go, oh yeah, that just becomes cos theta plus 2. You're not allowed to do that because there's a plus sign. It has to always just be multiplied. Keep that in mind. Good job. These two cancel out. And then obviously it's just cos times cos, which becomes
Cos squared.
cos squared on sine theta. You don't need to go and change cos squared to 1 minus sine squared. I mean, it's not doing anything to you.
Yeah.
If you write this, you won't get any more marks and you won't lose any more marks. It's just irrelevant. Just so you know. Oh, perfect. Eden, let's do this one. And then we'll get the boys going. So, to prove, what's going to be your first thing you have to write?
Left hand side.
Yes. I like hearing. That's how I know you're doing things my way. LHS, that's the first thing you write before even thinking of the question. Then you write LHS, 3 cos squared theta, take away 2. Look at the right-hand side. Just look at it. It says sine squared. This should already tell you what you're going to do. 3, and then?
Cos.
What is it?
Just be 1 minus sine squared.
Minus 2. What are you going to do now? Expand.
Right.
And then 3 take away 2. 1.
Yeah.
Minus.
Okay.
Don't overthink it. Equals RHS. Simple. Okay, next one. Lissandro, let's do this one together.
Alright.
What's the first thing you're going to do? What's the first thing you're going to write as well?
Rewrite the left hand side, sorry.
Left-hand side equals 1 on sine squared plus 1 on cos squared. What does your gut instinct tell you to do when you see something like this? Plus, cross multiply common denominator, yeah?
Yeah.
So that becomes cos squared plus sine squared over sine squared cos squared. And then, next line. What are you going to say for the top?
And then like split it up.
You want to split it up again? It was already split up. You brought it together. If you split it up, you're just going to go back to the original question. Look at it. Read this. You read this to me. Go.
Cos squared theta
Yep.
plus sine squared theta equals 1.
Ah, there we go. Good man. Over sine squared theta, cos squared theta. Now you stop.
Yeah.
And you go back to the right-hand side and you look at this. And you're like, wait, sec squared? Sec squared is 1 on cos squared.
Yeah.
And then cosec squared, or cosec squared is 1 on sine squared. And it's multiplied. So you already have it. All you've got to write now is same thing. Don't overthink it. Just keep working towards the answer. It's already there. Good job. Any questions for that? I think it's a good time to make something clear. If sec theta is 1 on cos theta, you guys got to understand, if this was like sec to the power of 3, sec cubed, that can be 1 on cos cubed. Like, it's not a problem. It's allowed. Okay. All right. Solving. The biggest thing with solving was we said, please do not inverse negatives. The first question is a negative. Don't inverse negatives, and then really just do all stations to central, and you should be pretty good. And just keep an eye on your domain. All right, let's start with Rad, because I think you're going to get this one out right. So let's start with you. Sine theta equals negative a half. So theta, and what are you going to draw?
Well, first thing I'm not gonna do the sine. Sorry,
Yes.
not do the negative. So
Yes.
you inverse the half, and you get 30 degrees.
Yep, and then I was usually writing this with a hat.
In the hat, yeah.
So equals sine theta of a half, or inverse sine, sorry, of a half, which you said becomes 30 degrees. Yep. And then?
And then, what would you do then? Then you do all stations to central.
Yes. Bang, 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 bang. Where is sine negative? You would say here and here.
Yeah.
So
And
therefore,
and then 180 plus 30, you'd get 210, and then 330.
and then what was the last line you have to do?
And is it the radians?
Yeah, you got to convert.
Yeah. You just go 210 on 180 and just add a pi on top.
Good man. You've revised your work.
Yeah.
11 pi on 6. Good job. Daniel, next one. Tan theta
Would
equals...
you inverse tan?
Yep, you're just going to straight inverse tan 3. And what does that become? 72 degrees.
Yep. All stations to central.
Yeah, since there's no negatives, this is all station central. Where is tan positive?
A.
I wouldn't know.
You don't know.
Is it A and C?
A and tan, T, A and T. And then 72, and then 180 plus. 252. Thank you. Done. And if you needed to convert 72 degrees, 2 pi on 5, and this one, 7 pi on 5. Okay. Math within 360. All right, Ethan, next one. Let's go again. Solve the equation cos theta equals to -1. However, we're going to put it into this domain, and that changes a little bit. But if you guys understand when I said you're allowed to add, and subtract as many 360s as you like, because you're not changing its location. It's always going to be here or wherever you're starting from. I think we should be okay with this. So watch how I will do this. But Eden, we're going to do it together. So theta equals what?
0.
0. So then you'll do your all stations to central, and you'll still ask yourself the same thing, which is, where is theta? Where is cos negative? Where is cos negative? It's got to be here and there. Yep. So the first answer is 180 minus, which is 180, and then 180 plus, which is still 180, right?
Yeah.
Now, this is what you guys got to understand. And like, if this was a 0 to 360, that's it. You're done. There's only one answer. What you guys got to understand from trig, and I think I showed this last week or the week before, I said they go on forever. So if I've got 180 degrees, right, and if I cos 180 degrees, and if I cos 180, if I keep adding 360 to 180, so 540, 900, 1260, 1620, 1980. What are all of these going to become when I cos them? What are all the answers? Cos this equals -1, right? I mean, when you the angle became 0, but when you cos them, they become -1. Do you get that?
Yep.
Because technically, you're not changing its position. You're just adding 360. You're just making the angle bigger. Same thing if I subtracted. So if I try to go 180 minus 360, which is -180, and then minus another 360 off that, -540, and just keep going all day long, right? What are all these going to give me?
-1.
Also -1. So what you guys got to understand with trig, literally your solutions are all the way from -infinity to infinity. And that's why they must give you a domain. Okay, when you understand that, and when you respect that, if you've got an answer and it says 180, but your domain's meant to be from -180 to 180, then you know if I had 180 degrees, if I subtracted 360 from it, it gets me 180 degrees, which is still in this domain. So my answer must be both of these. And that's it. Eden, does that make sense?
Yeah.
And I ignored -540 and 540 and 900 and -900. Why did I ignore all these other ones?
Because they're outside the domain.
Otherwise, technically, they all would still equal to -1. So they're all correct, yeah?
Yeah.
Yeah, all right, cool. Anyone have any questions for me there? So I think someone asked me, I don't know in which class it was, if it was the Thursday or Saturday class, I did say, oh, what happens if the domain changes? And I just said, it doesn't matter. If you're using my technique, I'm not showing you to do anything with the domain. We're not changing the domain at all. Your teachers will actually convert the domain. We're not changing our domain. All we're doing is actually understanding your answers literally go on forever. And if you understand that and you respect that, then realistically you just know I can add 360 and subtract 360 to as many angles as I want. So if I go up here, if I add 360, it will work. Like you'll get an answer to 210 plus 360 and then plug it in. But it's just outside of your domain. And that's the only reason why we're not writing those answers out. Okay. Let's do some harder ones. How are we going for time? Oh, very good. Okay. Lisa, let's do this one. Sine theta equals cos theta. Now that's just weird, right? Lisa, you there?
Yeah, sorry.
Why is this weird? What were you able to do straight away when you saw this question? What were you able to do straight away when you saw this question and this question?
You could inverse it and find the degree.
What can't you do in this case? Because you've got theta on both sides. You can't inverse sine a cos theta. That's just weird. So you would be stuck. Traditionally, our logic has been to bring thetas on one side, right? Or like, I mean, if there was x plus 5 equals 2x, you want x's on one side. So that's been our traditional way of doing questions, which is great. It will always work. It's just unfortunately in this case, when you're going to have them on both sides, it's still a bit useless. There it is. What can you do now? Can't really do much. You're still stuck. So this is a pretty unique question, and I think you'll get it out. What relationship do you know between sine and cos? So what's something that you know has both sine and cos?
The sine squared minus cos squared equals 1.
Yep, there's that. That's one relationship. What else? What else has also sine and cos? Say it. Seriously.
The tan.
Yep. See how I knew you knew that? That's why I'm saying say it. Sine theta on cos theta is also tan. Well, that kind of tells me, hang on, if I decided to divide this by cos and divide this by cos, is that technically allowed? Am I allowed to go divide as long as I'm doing it to both sides?
Mm-hmm.
Yeah. So what happens here? What's sine on cos?
Sine on cos is tan.
What's cos on cos? What's anything divided by itself?
0.
1, 1.
Oh.
And then, look, can you solve that now?
Yeah.
Of course you can. So the trick, what you guys want to all remember, I mean, maybe you would write that in a book where, like, that's a special question. You might not see that often, but it'll come up in an exam. Where if you've got a case like that, you have to actually divide by cos. So you got to get it to tan. And then after that, theta equals, tell me.
Is it just 0?
No, inverse tan 1.
45.
And then what are you going to draw?
All stations to central.
And then what are you going to ask yourself?
Where is tan positive?
Correct, here and here, which is 225. And the answers are pi on 4, and should be 5 pi on 4. Yep. Any questions there, Lisa?
No.
Cool. All right. Tiana, let's do the next one.
So we do
Do you like this
root
2 here?
3 over 2. No,
Yeah,
you bring it to the side. So root 3 over 2, and then put it in the calculator inverse, and then you get 60 degrees.
Oh, look at you on fire. All
Then
stations.
to central. You get 60 degrees in A, and then you do 180 minus 60 in S, which gives you 120. And then pi over.
Nope, and that's 2 pi. You agree with everything?
Yeah.
Good deal. Done. Thank you. Lysandra, let's do sec theta equals negative 2 over root 3. All right. Sec is bad. What are you going to do with sec?
1 on cos.
What are you going to do now when you see 1 on cos and this? You don't want it at the bottom.
Flip it.
Yeah, you're just going to flip everything. Because it's
Yeah.
on both sides, you can just flip it all. So cos theta on 1, right? And flip the side as well. Yep.
Yep.
And then theta equals, with a hat,
Equals 30.
30. And then cos is negative in S and T, so 180 minus 30 and 180 plus 30. And then convert. 5 pi on 6. 7 pi on 6. This one, I'll do this one. Sine theta, square root. You got to remember to write plus minus. 1 on root 2. If you ever have a squared, because you're going to have a plus and a minus, it's good that you guys can just get used to knowing it's going to be all 4 quadrants, right? You're going to have where is sine positive, well, A and S, where is sine negative, in T and C. So it's just going to be all 4. So really, I'm just going to find the first one, inverse sine, 1 on root 2, 45 degrees, and then I'm just going to go 180 minus, 180 plus, 360 minus. Let me know if anyone's got any questions for that while I work out the gradients. Okay, all good? Okay. Compound angles. Let's do these ones. these are the ones that we said, you know, you're just going to times it by 2. So therefore, you're going to get 2 sets of solutions, technically. But here we go. I'll do them now. Domain's still from 0 to 360, so watch this. Inverse tan, or actually, Rad, let's do this one together.
Yep.
All right, tan 2 theta equals root 3. So that's attached to the.
Yeah.
I've just got to make something clear. Hold on. This bit here, don't divide by 2 because it's not outside of your trig. So here we divided by 2 because it was outside my trig, and then we inversed. This is actually in the angle. So yeah. Now inverse tan root 3, which becomes 60 degrees.
Yep.
Yep, and then.
And then you get all stations central. Where's 10 positive? First and third, and you just go 60 degrees, and then 240 degrees. And you divide by 2. Oh wait, no. Oops.
You have to add 360 to both answers.
Yeah, you got to add 360 to both answers. The reason why we add 360 is because by the time you're going to divide by 2, you're going to get half of the answers only.
Okay, I see.
The way some students see it is if there's 2 theta, they know now there's going to be 2 sets of solutions. If there was 3 theta, you're going to get 3 sets of solutions. So you add 360 to these 2 and to the next 2.
Yeah.
All right. But I think it's good, again, it's a good time to say, get used to adding and subtracting as many 360s as you like. For the harder ones, especially. So if anything that's outside of your normal cases, add more, subtract more, it's fine. Probably better to do that because then you won't miss any answers. But we know now it's just going to be add 360. So 420 and 600. Yep. But you know what, Rad? I'm going to add more 360s. Like, look, add 360 to this as well. Right, we're just going to add it to 1 just to show you what happens. So 780. All good?
Yep.
All right, now divide. So that becomes 30, 120, 210, 300. And what's the answer to this one divided by 2?
390.
Yeah, and that's outside of our domain, so too big. Even though, do this for me. Do tan 2 times 780. Sorry, no. Do tan 780. Tan 780, because that's 2 theta. What does tan 780 become?
89 degrees.
No, tan 780. Tan 780.
Oh, 1.7.
Yeah, 1.73, which is root 3.
Yeah.
So it works. 780 is correct. It's not wrong. It's just outside of our domain.
Yeah, I see what you're saying. Because that's between 0 and 360, yeah.
Yeah, correct. So if you only had your 2 answers, you would have only had half the answers. So the reason why we're going to add 360 is just because of this 2 theta, the fact that you're going to be dividing by 2, you're going to need more solutions then.
Yep. Okay.
Because more angles will fit. That's the logic. Okay. Let's try this one. Sine theta minus 250 equals root 3 on 2. All right, again, I'm just going to inverse sine. $60 degrees. Then I ask myself, all stations to central, where is sine positive? Here and here. So my next answer is 120 degrees. Anyone have any questions up to this stage? Okay, now remember, I can add and subtract as many 360s, right? Now think about it. If I add 360 to these answers, I'm going to add 250 afterwards. It's just going to get too large. Do we understand that?
Yes.
Yeah. Would you take away 360s now?
Say it again.
Would you take away 360s now?
That would be very smart, right? If I take away 360 and then I'm going to add 250, well, it might just work. But look, if you're not sure, like which one, if you're not sure, okay, am I meant to add, subtract, just do more. I keep saying that. Do more. It's better than doing less. So we're going to add 360 anyways. just to show you guys what happens. So 420 and 120 plus 360 is 480. Now I'm going to subtract 360 from these guys. So 60 take away 360 is negative 300. And 120 take away 360 is negative 240. Ooh, negative 240, that's a good one. All right, ready? Theta equals, I'm going to add 250. 60 plus 250, 310. 120 plus 250, 370, too big. 250 plus 420, too big. 250 plus 480, too big. 250 plus negative 300, negative 50, too small. It can't be. It's got, the smallest number's got to be 0. Negative 240 plus 250, 10 degrees. That's your last answer that a lot of students miss. Because they're just not taught this bit. They're not. It's not emphasized. Plus or minus 360 as much as you like. I think I've emphasized it enough. And you'll know when to do it. Like, look, this is different to your normal sine theta questions. To your normal sine theta ones, you've got no problems. You're not going to add nothing, so it's not going to be an issue. If it's 2 theta, you'll know already I've got to add more. If it's these ones here, just be careful. Add more and subtract whatever you like until you're satisfied that by the time you're going to bring this over, there's not going to be any issues. Okay. I think I would like to do some HSC style ones, which are these ones here. Let me just see. Yep. We'll do these. These two are both HSC questions. So let's do AI. Show that cos theta tan theta equals sine theta. Oh god, it's so easy. Cos theta times sine on cos, cancel, cancel, therefore equals sine, which equals to RHS. Double A. 1 mark. Hence solve 8 sine cos tan equals cosec. Okay, a lot of things are happening there. So we know cos tan becomes sine. So 8 sine theta, cos tan becomes sine, so I'm just going to replace that to save me a line, equals cosec. Anybody have any questions up to this stage? I personally would not have written cosec either, because I know I can't use it. I would have written cosec as 1 on sine. Now, I know I don't want sine here, so I'm going to multiply it over. That becomes 8 sine cubed theta. Sine times sine is sine squared, times another sine becomes sine cubed, equals 1. Bring it over, 1 on 8. What are you going to do now? First, you're going to get rid of the cubed. That's not 3 theta, that's cubed. So you're going to get rid of the cubed, which is 1 on 2. And then doesn't that look familiar now? We've done 1,000 of those ones before. Theta equals 30 degrees, and then 180 minus, which is 150. It says go from 0 to 360, 2 pi. So pi on 6, and then 150 on 180. I'll just pause there. Anyone have any questions for me to this stage? You guys get what I've just done with everything? Cos tan became sine, and then that became sine squared, that became sine cubed, equals to 1. I brought the 8 over. I decided to cube root it first before you do shift sine, because it looks like this. Think of it like that. X cubed equals to 1 on 8. You have a cube root first, and then you're left with sine theta, and then shift sine. 2 marks. HSC, though, we're talking about. So that's why it's got a little bit more steps. And obviously, the reason why they've done stuff like that is because you would have already done some of the Year 12 content as well. So your math would have been a lot better to execute this. I simplify 2 cos squared b plus 3. Okay. Simplify. When I see cos squared and sine squared or whatever, and it's simplify, I'm thinking already of my trig identity. So I'm going to decide to change cos. You could have changed sine. It doesn't really matter. So 2 cos squared theta plus 3 sine squared theta minus 2 becomes 2. I said I'm going to change cos. It's up to you what you decide to do. Minus sine squared. Expand. Two and 2 cancels out. Minus 2 plus 3 just becomes 1 sine squared. That's it. If you had changed sine squared, I'm assuming the answer would have become 1 minus cos squared, and then you would have obviously just realized your last line to simplify would be to write that as sine squared. So either way, that would be the answer. Hence or otherwise solve this. Okay. 2 marks as well. Let's see how it's the same. Well, that's 2 cos squared. That's 3 sine squared. This says minus 2. This says minus 3. Okay. This is going to be interesting to see if you guys can understand what I'm about to say. All right. This is not this. It's close, but it's not exactly the same.
Mm-hmm.
So watch this. I want to write the question out. So the question was 2 cos squared theta plus 3 sine squared theta minus 3 equals 0. But I know 2 cos squared theta, so I'm going to literally write what I know we have, because it says hence, which means you've got to use the one on top. Minus 2, right? That's exactly the top. But you can't just change this to a minus 2. So what it is, it's that minus 1. The negative 3 is in fact minus 2 minus 1. And we know all of this is just sine squared theta minus 1 equals 0. Does everybody understand what I've just done there with the minus 3, how I broke that up into minus 2 and minus 1? Because the rest was the same.
Yep.
Yeah? Okay.
Yeah.
No? No? Eden, are you saying no?
I said wow.
Wow.
Yeah.
Okay. Yeah. Well, that's the idea. I mean, that's how you're meant to look at it. You're meant to start seeing your math like this, because we're talking about, again, we're looking at exam questions. We're not looking at textbook questions. So when you're at exam level, the idea is, the assumption is most students are already really good at this, like this step here. They're already really good at that because that's what they've been asked in textbook questions. So in exams, they're not going to ask that. They're probably going to ask more questions like this. They'll just make you think a little bit more. But
Yeah.
as always, as you expose yourself more and more to exams, you'll get used to the thinking, and then it's really easy. Squared, exactly like we said before. It's just going to be all 4 quadrants. So 90, 180 minus 90 is still 90, 180 plus 90 is 270, 360 minus 90 is 270, and you are done. Any questions, you guys? I'll stop this recording now.